thank you all that came here in person and also on Zoom. We really appreciate you guys turning out. My name is Jeffrey Gillen, and I'll be your instructor. And you found yourself in our weekly seminar called NextGen Geospatial. And so every single week we're going to do something new. We'll kind of expose you to a new tool or a new idea, but we can't go too deep. We just have 1 hour together with each other, and so it's kind of like, here's this thing, and then we're going to leave you with resources to explore deeper. Of course, we leave our contact information in case you want to reach out to us and learn more about the tools. What else? Let's get this off and start looking at the actual content. Okay, so we use GitHub as kind of our hub for our educational content. It's a great place to put information on, and hopefully most of you guys are familiar with GitHub, but it's very easy to navigate. The content should be, what's that? That's okay, am I not? Okay, sorry, thank you for letting me know. Share. Okay, now you guys can see it, right? Yeah. Okay, this is the course homepage. So this is where we're going to find all the content of what we're doing every single week. So like I said, we just have like a short hour together. Hopefully everything we cover is a little different than what you guys see in your accredited courses at the university. So let's go down to our actual content. So purpose of this course is to show you a few things. A lot of it's going to be kind of AI related, and a lot of it's going to be cloud related, all about geographic analysis. So for today, we're going to cover something called CyVerse Geospatial. Talk about what CyVerse is, and show you kind of a suite of tools that are available for people that are interested in doing kind of larger scale computation here on campus. And then every week we do something new. So next week on Tuesday at the same time, I'll give an intro to Google Earth Engine. So this is just basically what is it, how to get access to it, why it is powerful, why it's a tool that everyone should, kind of have a little bit of a handle on. And after that, we get into, we have 2 sessions on deep learning. So I'll show you how to use a deep learning model on some aerial imagery. I'm going to give you Python notebooks so you can actually work with it on your own time, show you how to fine-tune a model, basically get you started with deep learning if you've ever wanted to do so with aerial and satellite imagery. And then we get more into the cloud stuff. We talked about cloud optimized geotiffs, cloud optimized point clouds. You'll learn about more about what they are as we go on. In October, I'm going to do something called, let's see, interesting. Sure. We do something called reproducible pipelines. So a lot of kind of our emphasis at CyVerse and the Data Science Institute, where I work, is about reproducible research. So anytime we create some kind of intellectual property or research product, we want to make sure that it is shareable and usable by other people. So with this one, we're going to talk about how to put together like a pipeline of different scripts and then hand it to someone using software containers. We'll get into geospatial data APIs. And so I'll teach you how to use Python to find and download data and bring it right into a Python environment. And this will be from Planet Labs data. And then we'll finish with spatial temporal asset catalogs, which is kind of an open source global catalog that we're all trying to build. So yeah, I hope you guys will join us throughout this whole series. It's not required that you attend them all. We set it up in a way that each lesson is discrete. So if you can only make 1 or 2, great. But I think if you stick around and watch all of them, that you kind of have this baseline and a good skill set to do geospatial data science on the cloud and be able to share it with people in an impactful way. So let's get into today's session. Like I said, we don't have a whole lot of time together, so we're going to talk about CyVerse Geospatial. And I can go right to my Oop, that is not the button I wanted to hit. Uh, Okay, so for today, we're not going to do any coding. We're not going to do any Python notebook or anything like that. So you can just kind of sit back and observe, take in what we're talking about. So CyVerse Geospatial. I think I mentioned I work for CyVerse and the Data Science Institute here at U of A. And so what is CyVerse? So CyVerse is our in-house cloud computing platform here at the University of Arizona. It's actually in UITS. The hardware is right here, and it is free for any U of A personnel to use. So students, staff, faculty, can get free access. So what is it? It is a cloud computer. And the idea is that it feels like your laptop. You do connect to it through your laptop or your desktop computer through the internet. So you're basically using a web browser to access this cloud computer. And it's going to feel like your laptop. It's a graphical user interface, and you can click around and do things. But it feels like your laptop, but with a whole lot more compute, a whole lot more RAM, a whole lot more storage. So like anyone can use this at U of A for free. And there's a long history with this project. So I believe this started in 2007, 8, is that the time frame? So it used to be called iPlant, and it was specifically about having computational resources for people that were doing plant science. And they opened it up, to basically anyone doing any kind of work, because there's a whole lot of people doing high computation that are not just in plant science. So it was rebranded to CyVerse. It originally was funded by the National Science Foundation. It actually was the largest cyber infrastructure project that they have ever funded. We are no longer funded by NSF, and so we really have redirected our energy towards the U of A, and we are trying to be kind of a must-have resource across campus, and we think a lot of people will get a lot of value from it. Okay, so you can either follow along or you can just access the website after this. It's kind of up to you, but to get started, you go to cyverse.org, and so that is our homepage. I'll just go ahead and click on it. Is that really the thing that I wanted? Is this the new homepage?
I never know what website.
Yeah, okay. Well, at cyverse.org, there should be a button somewhere to log in or sign up. And so again, that's the first step, is just sign up. We'll take your U of A credentials, get you an account, and then you're ready to go. Once you get an account, once you get signed up, here's a link here. There's a self-guided course if you're interested in kind of learning a little bit more and going a little bit deeper and figuring out kind of the ins and outs. But I'm going to give you kind of the bigger picture of what CyVerse is and what it can do for you in terms of geospatial science. So the thing that is probably most immediately useful to people is that it is a large cloud storage. I'm sure people in all disciplines, not just geospatial, have data storage limitations. And so if you're here and you're U of A personnel, you can get yourself an account, and you can automatically get a pro account, which is up to 3 terabytes in size. So if you guys have large data sets, CyVerse Data Store would be a pretty good place to put it. So it's sort of similar to Amazon S3 or Microsoft Azure Blob or Google Cloud, things like that. It's built in the same kind of way, or it's supposed to act kind of similar. Like I said, 3 terabytes storage. What else? It has a lot of ways to get data in and out. So you can interact with the data store through graphical user interface, through the website, or it can be done all programmatically. There's all kinds of command tools to be able to access the data, put data in, take data out. A lot of things can be automated from CyVerse. So it's just kind of a good hub, a good place to put large data sets if you have if you have them for your projects. What else? We love cloud storage because then it becomes something that's shareable, right? I was trained kind of on the closed science model, and I've got terabytes and terabytes of data on hard disks, and no one in the world sees that really besides me. And so we are trying to like kind of destroy that paradigm and get people's data online, because then it is shareable, it is open, it's reproducible. I can just send someone a URL or a link to my data, they can download it. So it just makes collaborating with your peers and your colleagues a little bit easier. And CyVerse is also very social. And so you can have your personal account, but then you can connect with the people in your project. And so you can all share data together, things like that. So yeah, so probably the number one thing people get value from is just the data store. And it's the easiest to explain to people. Would you like a big storage that is on the cloud that can be shared with anyone? CyVerse.org. Okay, so that is the data store and sharing. So when it comes to geospatial, the next little bit here says share your cloud native geospatial formats. Has anyone here heard that term, cloud native geospatial? Kamal has. All right, so what is it? It's kind of what I've just been talking about. It's trying to get away from the model of downloading data. It's since we're using cloud infrastructure, with the CyVerse data store, why do people have to download large files to their own computer? And so we can do a lot of analysis, a lot of work just all up in the cloud. And you don't have to bring 20 gigabyte point cloud or 20 gigabyte geotip down to your local machine if you don't want to. So cloud native geospatial, I'm going to give two specific sessions on it a little bit later. And so that's really going to fill you in with details on how they're useful. One I'm going to cover is called a cloud optimized geotiff. Another one I'm going to cover is a cloud optimized point cloud. So geotiffs and point clouds are very typical data products in geospatial. But cloud native means the format has been tweaked a little bit. It's been tweaked, and so it is optimized for HTTP. In other words, streaming. So the analogy I like to use, and this is probably going to date me, is, we used to download music. Remember that? There's something called Napster. We used to trade music and download it. I know that's like 20 years ago now at this point, but how many of you are consuming media, i.e. like movies or music through download? Probably not a lot, right? Oh, this guy. This guy's hoarding movies. Yeah, so how do we watch movies? We usually stream them, right? We stream them on Netflix, we go to YouTube, we watch whatever, we stream music over Spotify. And so we can do basically the same thing with geospatial data. We don't have to download big files. It can live up in the cloud, and when we want to use them, we can stream them to our machine. And so it brings up makes possible a lot of efficiencies. I don't have to bring over 26 gigabyte point cloud. I could bring over just a little bit of it. So it's the same technology that we have for streaming movies or music, only we can do it with raster or vector or point cloud geospatial data. So I bring that up because CyVerse is an excellent place to do that. You store your data on the cloud, and then you can stream out these data products to anyone in the world. Like I said, we're going to do 2 other sessions on that, so we'll really get into the details of how to use them. Let's just do a little demo here and see if this works. So this is an example of a cloud optimized point cloud. Let's see, I just want to open it and link a new tab. Okay, so what you're looking at is a drone-based photogrammetric point cloud. So I flew a drone over Paradise Valley Country Club, a year or so ago, and made a nice little point cloud. And so this is a cloud optimized point cloud. So this point cloud is rather large. I don't know, it might be like 5-6 gigabytes, and it's sitting in CyVerse data store, right? Sitting on the cloud in our cloud storage, and it's being streamed out to this web application viewer. So this is a web viewer that's created by a company called Hobu, or Howard Butler is the guy behind it. But yeah, it's just an example of you can take data that's in storage and stream it to an application. It could be a website like this, or it could be into your Jupyter notebook or a Python environment or the RStudio. And so it makes this things so much easier in terms of visualizing and sharing with your friends. And this one was really fun to do, the flying, that is. This was about a subsurface drip irrigation project, and they wanted a really detailed 3D model. And so I flew the drone and shared it with them. And the golf course manager was like super excited when he saw this, because he doesn't have specialized point cloud viewing software. But we can just stream it directly into a web browser. Yeah, Chad.
I was just asking if you could take like simple measurements on this.
I believe so. I'll show another example later in the semester using a poetry viewer. This is a specific proprietary thing that Hobu made. And I wonder if is there like a little measurement tool in here? Could be, there might be little measurements, but for the most part, what I'm showing you is more just a visualization tool. All right, let's get back to where I was. CyVerse Geospatial. All right, it's 2:19. I think we're doing good on time. All right, so the next thing I wanted to mention with CyVerse is permanent archive. CyVerse is also a great place to just like park things. We think that there are specific repositories that might be better than CyVerse, but if you don't find a home for your data, you can put it in CyVerse, and it can be kind of like a permanent link, a permanent place. And so we can issue a digital object identifier, or a DOI. And so if you publish a paper, all of your data can just sit in the CyVerse data commons, and then anyone in the world can access it. So I published 3 different papers, and then all the data is sitting in CyVerse. And so when someone brings up the pub, they see a link for the data set, it'll go to CyVerse, and they can download it or stream it or whatnot. So that's another feature we have, is the data commons, which is like the forward, like public facing aspect of the data store.
Can I ask a question?
Sure.
For those of us that are trying to follow along with you, is there a way that we can get to the page that you're on? So did you go to a geospatial tab or something?
Carlos or Michele, could you please paste that link, that GitHub link, into the chat?
Yes.
Yeah, it's just a GitHub page, that has all of our content. So my guys here should hook you up in 1 second.
Share.
Thank you.
Okay. Yeah, you're welcome. Okay, so we talked about the usefulness of storage of CyVerse. Now let's talk about computation and actually like do an analysis. And so CyVerse is basically, it's 2 big things. We have a data store, and then we have the actual engine. And so we run something called a Kubernetes cluster. There's no reason to you guys to specifically know that, but it means you can do your computing through CyVerse. You access it through the web browser. And so you can launch programs you might know, like RStudio, Jupyter Notebooks, QGIS. You can launch those directly in CyVerse, and then it pairs with your data store. And so that to me is like the real like power. So you can have 3 terabytes of geospatial data, and then you have your analysis application right next to it. So you want to do Python or R analysis or QGIS, it's just like right there. So let me show you an example of kind of what that looks like. Let's go to home. Okay, so when you guys get an account, I don't expect you to remember this interface or whatever, but when you get an account, you're going to be generally working in something called the discovery environment, or we call the DE. All right, this is kind of your hub. It's a place where you can access all your data. And so here's my folder of data, and I've got how much like total does it say? I have 4 terabytes of data in CyVerse data store at the moment.
You all have 3 terabytes if you
Yeah.
sign up today. using your Arizona account.
Yeah, so we've made this really easy to use kind of graphical interface that you can just click with the mouse. But if you're more of a power user, you know, you can do things more programmatically. So I can check out my apps here. So this is just a few of our kind of our featured apps, but we have all kinds of different applications you can run. If you are a more advanced user, you can create your own application, and we can containerize it, and we can then launch it on CyVerse if that is, you know, your what you like to do. We can customize and work directly with anyone that would like to use their application or their analysis on our system. Yes, sir.
How can you connect with the CyVerse data storage? Like if I want to use this data space and some kind of other application outside, like is it similar like Azure or AWS S3 bucket or something?
Yeah, if you want to, okay, so the question was, how do you interact? So if your data is in the data store, how do you then interact with other applications, right? Like third party somewhere else, right? So yeah, we have all kinds of input output tools to do that. And so it shouldn't be too tough, but we'd probably have to get specific with what you're trying to do. But yes, it was built for that. Think of CyVerse as where things are, but then they can be sent anywhere you would like them to go.
And you just saw an example of what Jeff showed you was the application talking to data in there. It was an HTTP endpoint.
Was there something in the chat? I don't know how to find the chat from here. Here we go. What would you like me to look at?
Can you click on Teams so we can see you listed? I don't know. what this person-
Okay, Alan. Okay, Jeffrey, can you click on Teams so we can see you listed? Okay. Alan, can you be more specific? Are you trying to see my user account or who I am? I'm not sure why it's not coming up. All right, well, we'll just continue.
I was just looking to see if the team showed up there, the one that you had in your documentation. It didn't show up in my discovery environment. You know, the UA FOSS one.
Probably because you weren't added to it. So
Oh,
if you're not a
okay.
member of the team, you won't see it.
Good, thanks.
Okay, and yeah, we can offline, you probably address that. So please reach out to us, Alan. Thank you.
Question for you, Jeff. from the
Yes.
chat. Is Agisoft for drone stitching supported?
We shall get to that. Okay, I came to the discovery environment for a reason, right? Okay, I showed you the data store. I wanted to launch an app, and so in here we have a list of our featured apps. So for example, if you're interested in QGIS, you can do that. If you're interested in many flavors of Python, Jupyter notebooks, or different flavors of RStudio. Let's try something here. Rocker. Okay, so live demo. We'll see how it goes. And so we made this so you could just click through. And so I'm like, I would like to start an RStudio instance. And you actually have the ability to adjust your resources. How many CPUs would you like? How much memory? How much disk space? I'm just going to hit the defaults and we'll get this thing launched. I'll go to my analysis here. Hopefully it doesn't sit at 60. There we go. So anyway, so this is an alternative to doing applications or analysis on your own machine. We think that doing things on the cloud can be easier and more powerful in a lot of ways. So yeah, you probably have RStudio on your own machine. Nothing wrong with that, but if you can use CyVerse because you'd have 3 terabytes of potential data storage that you can then run right here in RStudio, and also gives you the ability to share out. So it's just kind of nice to be able to start a clean instance of a Jupyter notebook or an RStudio or whatever and use it for your purposes. And then it disappears. So that's the one thing about Kubernetes clusters. These things don't persist forever. You're in a session and you can use it, but then your session will eventually time out. And then whatever you're doing just kind of goes. So it's not a place you work at forever. You work on it for a little bit and then save what you're doing to the data store, because the data store persists, but our applications do not. They are, I'd say, ephemeral or kind of temporary.
How much time do we have for instance?
How much time is it?
So that varies on what the author that put together that, so it's anywhere from 4 hours. And maybe Jeff, you can show them the analysis window where there's a button where you can ask for more. So you see the hourglass next to the thing, and when you click on it, it'll add 4 hours or
There
whatever
we
is
go.
the duration that is set up to give you more up to
Okay.
what from your
Okay,
Hello, sir. Do you mind muting your microphone?
I'm so sorry.
No problem. No problem. Okay, so I currently have 2 applications running, and I have an instance of QGIS and an instance of RStudio. And so there you can have several launch at the same time, but they will eventually time out. And you can, if you're still working on it, you can always just extend the time. Yes, sir.
If you have code that's running that might take 5, 6, 7 hours to run continuously, if that's longer than the timeout, it will just kill your code that's running.
Unless you kind of preemptively have a better idea. But in general, yeah, you won't be able to run analysis for like days on end. I do not think so. Okay. So
So-
that's the discovery environment. There's definitely more to it, but that's the meat of it, is that we have, you can click a button and start different analysis applications, and you have that right next to your data store. And so that's, really powerful and probably a little bigger than your laptop. Okay, what other kind of highlights here?
So is there no way to store the program that you put together? You can't clone the code?
Cloning the code. Okay, so you're talking about like an application. Let's say you have an analysis. Is that what you mean, sir?
Well, you do, yeah, you write some code in your Jupyter notebook and you come up with a solution for something, and then you want to save that code for another day. Is there not a way to do that?
Yeah, there's definitely a way. We would recommend using something like GitHub or like
Okay.
a third-party version control.
Okay.
That's typically what we use in terms of our code. We don't really
You can
store
also
code specifically on CyVerse
yeah,
generally.
you can also put your code into the data store. So when
Oh.
you run these applications, your personal folder is mounted as another folder. It won't necessarily be the home folder, but it's another directory that you can copy your file into before you turn it off. But make sure
Yeah.
it's copied out.
Got it.
Thank you, Tyson, for the color. Okay, I don't think we need to talk about advantages of cloud computing. Well, it's nice because we handle the infrastructure and everything, and you can just tap into it, and it feels like your laptop. I like cloud computing because I can go from home to my office, and my analysis and what I'm doing is in the same place. Long ago, I stopped carrying drives from like one place to another. When you work in the cloud, it's just there. No matter where you are, you can tap into it. Okay, so that was pretty much what I wanted to mention about CyVerse, the discovery environment and the data store. So I encourage you to, check it out, cyverse.org. You can get free accounts and start doing this stuff. If you have any questions, you can always reach out to me. My contact information is here. It's here somewhere on the homepage. Is it? Yeah.
Jeff, for people who are signing up for accounts, it takes anywhere from 15 minutes to an hour. Make sure you have Arizona.edu. That's the only way we can recognize that you are a U of A person.
Okay, yeah, Nirav said that, yeah, if you sign it up, there might be a little delay, but please use your Arizona.edu account. So we knew who you are. And so then, you know, we can get you your pro account kind of immediately. All right.
There's a question in the chat that you may want to answer.
Okay, Jeremy, here's an older MacBook that won't run some programs. Could I bypass upgrading my laptop by using CyVerse? That's not a bad use case. Yes, I think you could. Of course, all of the applications that you might want to use on your MacBook, maybe some of them we don't have in CyVerse, but yeah, as long as you can pull up a web browser on your MacBook and tap into CyVerse, then yes, you are correct. If there's any specific applications that you would like to run on CyVerse, then you can contact us directly and we could probably do something to help you with specific apps. We typically work with open source stuff. And so if it has a license, you know, if it's like MATLAB or something like that, we generally don't do that, right? It's usually open source, right?
So
Or-
there is a MATLAB version that people can use if they want to, but we encourage them to compile it as an application.
Yeah, okay.
There are better places to run MATLAB.
For instance, we don't use ArcGIS or ESRI products. You can get that education and those tools anywhere else at the university, and we kind of focus on the open stuff. We like QGIS, and then geospatial scripting languages like Python and R is typically what we use.
I have two questions. Does any or each application come with an environment setup? Like, I don't know if I'm using this code or any Python environment. Does it come with a set of frameworks and stuff? The second one is if I can save a snapshot of the instance. Like for example, if I'm using RStudio and want to, I don't know, do any spatial analysis, I need to install their so it takes time. So every time opening the instance and trying to do the same will be, I don't know, a kind of issue for me. So
Yeah, I can address that. So the question was, when you launch an application like VS Code or a notebook, you know, Python notebook, does it come with things pre-installed? Yes, we do have like featured apps and like already installed stuff. So we have many flavors of Jupyter notebooks that have this installed, that installed, PyTorch, whatever. But we can also build custom ones. Like if you have, I need this software stack to, you know, to be able to launch so I can click and be right into it. You know, that's what CyVerse is kind of built to do. But you need to contact us directly to make that happen. You could also launch as like a blank one that has nothing installed if you want, you know, clean and you want to install everything as you go. So it can be kind of customized to your interests. So yes, things can be pre-installed or not, depending on your specific interest. Sure.
Feel like using CyVerse as an open source platform for coding. So, like, how efficient is it in handling the GPU consumption?
GPUs. So that's a GPU question. Okay, I figured someone might hit that. CyVerse discovery environment itself is not set up for public access to GPUs. If you would like more GPUs, we can probably help you get on the HPC or into our sister cloud computer called Jetstream 2. So both of those are actually much bigger and have yeah, more computation, like larger nodes and more GPUs that are available. Does that answer your question? So yeah, it could be the HPC or Jetstream 2 is where I would kind of direct you if you're doing specific like ML deep learning kind of stuff.
If you're doing inference, there will be GPUs that are available, so you can feel free to reach out to us, but as Jeff pointed out, Jetstream has A100s, soon H100s. And so depending on what you want to do, we can point you to it. And each of these sessions will also have a roadmap for you. So how do you go from your laptop into CyVerse, into Jetstream, and any of the NSF environments? And it's pretty straightforward to get access to those. But you have to know how to organize your code and your data to make use of this. And you have to write about a page of description.
Thank you for the question. Yeah, we get that one a lot. Okay, so there's a few other things I wanted to mention regarding geospatial and the world that we inhabit. One is planet satellite imagery. And so the Institute for Computation and Data Enabled Insight, or ICDI for short, it's here at the U of A. It's kind of like our partners. You know, we're right next to each other on campus, and they have actually purchased a campus-wide license for planet satellite imagery. And so anyone that's affiliated with U of A can get all kinds of satellite imagery for free, essentially. But you have to talk to us. You have to kind of go through us. So if you are interested in getting free planet imagery, there's a little button here that can help you kind of direct you to sign up, and then we can get you started, or you can just email me directly. If you're not familiar with Planet, so Planet is it's a company, it's based in the Bay Area, and they have like more than 200 small satellites orbiting Earth, and just around the clock, they are imaging most of planet Earth at 3-meter resolution and 4 or maybe even 6 bands by now. So for a lot of geospatial or image analysis, Planet is a really good option. It's 3-meter resolution, so it's much higher res than like a Landsat or a MODIS or things like that. But it's not going to be as high as some of your other commercial ones. You know, there are some satellites that are getting to like 1/2 meter or 1/4 meter in resolution. So the scale is really dependent on what your question is. But this is just a wonderful free resource. If people are interested in getting Planet Lab imagery. And what's great about it is it's almost near real time. So if something happened yesterday, you could get the imagery today or tomorrow. It's captured by satellite, and then it's available on the web very shortly afterward. And so the typical thing that people get is the Planet Scope, which is the stuff they're just collecting around the clock all the time. So if I want to go to Tucson, I look at this date range for Tucson, let's say September 2023, I'll probably find 20 to 30 images, little different times, but like there's a lot of data, and you'll find something that'll probably help you out. So besides just the Planet Scope, they also have a global archive of RapidEye, which is a different satellite. I don't actually know that much about RapidEye. And then there's something called SkySat, which is tasking. So if you I would like satellite imagery of this specific location on Earth, talk to us and we can probably get that tasked out. There might be a fee, or I think we have some kind of allocation that it would be free. So again, it's a really great resource. What else? They also have something called planetary variables. So Planet, beyond just selling imagery, they are doing analysis. And so they have products like soil water content, land surface temperature, forest carbon. So they're trying to do these more value-added products that people might be interested in. And so, yeah, through our campus license, you can access some of that. What else? I think that's pretty much it with Planet. So yeah, if you're at U of A, you can get a lot of satellite imagery for free. So take advantage of it. Let us know. You know, we've already prepaid for this, so we'd really like to get our money's worth. So please take some satellite imagery. All right, it's 2:42. All right. And the last thing I want to mention that we have some free access to is a photogrammetry software called Agisoft Metashape. So I've been using this software for probably about 10 years. It's primarily used for aerial photography and drone-based photogrammetry. And so maybe that's a little niche for a lot of people. Not everyone's doing drones and stuff, but if you are, this is a really great software. It's the best in the world, in my opinion. And we have 20 licenses that we can let you use for non-commercial purposes. And we really would encourage you to use it if you're using like the HPC or Jetstream 2. I think there was a question earlier about Agisoft. We would prefer, we don't really do Agisoft on in the CyVerse discovery environment. I think you could, but it's like, it's one of those things where it's probably better if you do it someplace else in our, our partner institutions like the High Performance Computer, HPC, or on Jetstream. So if you're interested in really scaling that up, we can help you to do distributed processing across several processing nodes, how to use GPUs, things like that to really make it go fast. So I've used Agisoft a whole lot when it comes to making photogrammetric point clouds, digital elevation models, all these drone-based photogrammetry products. And so, yeah, we have 20 educational floating licenses that anyone can use. If you just contact us, we can hook you up. Oh yeah, there was one. Oh, there's a couple more. A couple more items on the menu. I mentioned Jetstream 2. So Jetstream 2 is kind of our sister organization. They are based at the University of Indiana, and they are an NSF-funded cyber infrastructure for the country. And so they have a very large cloud computer. And if you write a little narrative of why you would like access, you can get access and get pretty much all the computing you need. GPU, CPU, storage, if you really need a bigger computer, we can help you do that through Jetstream 2. And we have an in-house product that we make called Cacao. So it was developed by the software engineers that we have here at CyVerse. And Cacao is an interface that talks directly to Jetstream. And so we call it infrastructure as code. So it is a very interesting way to build virtual computing environments. Let's say you have a whole lot of drone imagery to process, like terabytes and terabytes. We can build a Cacao template with basically the push of a button will launch all these virtual machines, provision it with all the software you need, and then kick off an automated script to process them all. And then when it's done, it just goes back to hibernation. So it's a very interesting infrastructure as code tool if you really are trying to do big computation. What else? I think Cacao can probably be deployed. It can be deployed on commercial cloud yet on Amazon. So it was built for Jetstream 2, but it could also be used on Amazon. And like I said, yeah, it will build and provision virtual machines for you to do large scale computing in kind of a very quick templated type of way. So yeah, most people probably don't need to go to that level. But if you happen to be, a PI or kind of doing real big stuff, then we would love to help you out. And it's 2:46. So I'll cut it right there in terms of content. So we talked about what CyVerse is, that you guys have free accounts already. So go ahead and log in and get yourself a pro account with 3 terabytes of cloud storage. If you would like to use our computation in the discovery environment, we can give you a little guide on how to do it. We talked about planet imagery licensing, talked about Agisoft Metashape licensing. So anything geospatial related, please come and see me. So I'm available for consultations, any kind of geospatial stuff. I could maybe send you in the right direction or give you a little advice here and there. If you guys are interested in partnering, deeper integration or getting involved in grants together, we're certainly open to that as well. Oh, any questions around CyVerse and geospatial? Yeah.
You mentioned the like streaming data and we don't need to download the data. So through CyVerse, how do I access data through CyVerse? Do I need to download it through the through CyVerse or like how do I get the data?
Okay, so it would have to be like someone would be sharing it with you. And so a lot of like institutional data, maybe it's from the government or something, is not currently on this wagon yet in terms of streaming data. So think of it like open science. So if you're doing research and you have created a lot of data, then you can make it available to anyone who wants to consume it. Yeah, if you're looking for, are you looking for like data from the government or something like that?
Ameriflex data, for example.
Okay.
What is data that I use to work with? So is it exist there or I need to download it?
Yeah, no, it probably doesn't exist. Yeah. That would probably be, we need to have a conversation with Ameriflux or whatnot to put data in something like CyVerse. There are a lot of agencies like NASA and the USGS that are becoming more wise to this. In addition to offering download, they're trying to offer it as cloud optimized geotiffs or optimized point clouds. But yeah, if you are currently looking for data for your project, CyVerse is probably like not the place unless you specifically know someone that has data in CyVerse. So it's not like institutional data is massively represented in CyVerse. And Tyson, you might have some comments on that. Do you? Are you online still?
Yeah, I'm here. Sorry, could you repeat what you were saying?
She was wondering about getting I talked about cloud native geospatial, and she was curious, like, well, can I go to CyVerse to get data from Ameriflux towers or Modis or something like that?
So there are canonical repositories for large data sets, like the eddy covariance data that are out there. In the past, CyVerse has supported projects like the Cheesehead project out of Wisconsin, and they were caching their eddy covariance data on CyVerse. So yes, you could put your data in CyVerse and then use it publicly. You could also write a script like a Jupyter notebook to pull data from the eddy covariance API network, process it in CyVerse, and then either put it in the data store or push it somewhere else.
So yeah, if you're looking for institutional data, you're gonna have to go to the institution. I guess CyVerse is more about facilitating the individual, in terms of sharing data.
If I would just add.
Please.
So the question you asked, CyVerse is a place where you do the analysis. And if the data exists somewhere, the job is not to make a second copy for the sake of it. So if now you're doing a team analysis or even your own, that's when you bring in the data and then you can keep it in a place where the team can work around it. And each of them doesn't have to now bring that down. But we don't make it open because if you have copies of the same data, then you're adding confusion to people where they can find it there, they can find it here. So if you just, for example, you got Ameriflux data and said, I want to make this public, we won't let you do that. We'll say, Ameriflux already has it. What is your reason to make it public? And then you say, oh, I've modified it, I've done this, and nobody wants that modification, but here's a community of researchers that will benefit, and it's also in my paper, then it's a different conversation. But first step for any of you, once you have data that you want to work with, you have to stage your data, you have to bring it in, because we don't make copies. Now, there are projects, for example, the Maricopa, the robot, the field robot that does phenotyping, and it's producing data every day. It's shipping it to CyVerse, and it's supposed to become public within 24 hours. So if your project wants to use that data, that project is designed to put its data into CyVerse as a canonical repository. But that's the only place on the internet you'll find that data. So if that's the case, you will find it, but otherwise, we won't make copies for that very reason, to prevent the confusion of having the same data in many places.
Okay, well then we will leave it at that. So thank you guys very much for coming to the first session of NextGen Geospatial. Reach out to us, if you have any questions about anything we talked about today. And hopefully I will see you again next week, same time, Tuesday, 2 p.m. here. And I will give you a introduction to Google Earth Engine. Basically, how do you get access to it? How does it basically work? Why would you want to use it? Kind of the power behind it, how to make an app, through it, things like that. So it'll be very high level. What is it? How you get access mostly. So, all right. Thank you very much. And we'll see you next time.
Thank you.